Welcome to the Virtual Berlin Droid August 2020 meetup. We have 2 talks prepared today, and with we, I obviously mean somebody else but me. In this case, it's Nicole Turk talking about Composite ViewModels. Then we will have Akshay with Go with the Flow, talking about hopefully the Kotlin flow and not any other flow. And then we were also preparing this Slido link. We will look through the questions there and ask the speakers the questions after their talk. So if I will also share this link in the Hangouts in a second, but feel also free after the talk to just ask the questions directly. Either way, if you feel like talking or if you feel like writing, we take care of that your questions are getting answered. What else do we have? We have some more Android, and especially when you want to contribute more Android. So in this case, if you want to be as cool as the 2 speakers we have today, feel free to scan the QR code. I like this QR code. It is an actual working QR code, and I should stop speaking about QR codes in a second. Once you've scanned it, you will find our forum, our Google Forms, where you can put in what you want to talk about, add links and whatever we need to make a decision, like if we want this talk or not, or if we can help you making this talk even better. And that said, this is already the meta talk, right? So we have hopefully another monthly meeting is September the 30th. And with that, my presentation is over. And I would say, Nicole, do you want to take over and take it away?
Sure. Let's take away your power. Oh, whoa. Remove that. Let's see. Perfect. You should be able to now see my beautiful presentation.
Yeah, so I see your beautiful presentation.
Perfect. As Mario was saying, my name is Nicole Turk, and today I'm going to be talking about composite view models. Before starting with the juicy parts, of course, we need to review some basics. And of course, the first basic of those is view models. Of course, as Android developers, you're already pretty familiar with MVVM, view models, and have some kind of version of this simple diagram already drilled in your brain. And of course, you're also really familiar with the basic principles of view models, which is to have all the core business logic inside the view model and make the view as dumb as possible and only handle the UI changes. So far, so good, I guess. I guess all of you know view models, I hope. Now, for a more lengthy and complicated principle, well, named, is the unidirectional data flow pattern. Don't be afraid, you're probably already familiar to this one. But for those who aren't, this pattern basically relates in 2 basic concepts. The first one is view state, and the second one is events. So what are those things? First of all, the view state is going to be an object that is going to be holding all the data and information necessary for the view to show something to the user. This can be like the simple list of items that are going to be shown in a list, or it can be like an empty object that is going to be letting the UI know that needs to show like a spinner or something like that. So some examples of this view states can be, as I was saying, like loading state, data loaded state, yada, yada, yada. Now, the events are basically going to be objects that are going to be containing or representing the actions that are happening on the view. So this can be like user triggered actions, like a button was clicked, the view was clicked, an item was clicked, something was clicked. Or they also can be life cycle events, like an on resume, an on stop, the view was destroyed because of reasons, you rotated the thing. Whatever you can do on the view can be translated to an event. Okay, those are the 2 basic concepts, but how those 2 like relate to each other and how this pattern works. But a really simple diagram is something like this. Basically, what is going to be happening here is that the view is going to be the one creating these events, because it's the one that is going to be receiving them, like when the user clicks, as we're saying, or when the view is rotated or whatever. The view is going to be the one in charge of creating these events. Now, these events are going to be sent to the view model, and the view model is going to be the one in charge of reacting to those events, doing something, creating a new state for the view, and in its part, the view is going to be listening to those state changes and react to it. Okay. As I was saying, you're probably already familiar to this, and you probably have something similar to this in your projects. If not, it's a really nice pattern that you should play along. But of course, this doesn't tell the whole story. So let's see a nice, simple implementation of this. Okay. If you apply the unidirectional data flow pattern, you end up with a view that looks like this one. Basically, this is a simple activity that has the view model. It is just triggering some lines load event when it resumes, and it's going to be observing to the changes on the state from the view model. So whenever the view receives the state change, which is represented by this nice one here, it's going to do something on the UI. So for example, when it receives the loading state, it's going to start loading, showing the spinner. When it receives the information that it needs to show, it's going to hide the spinner and submit the information to the adapter. And if there's an error, it's just going to show a toast. Okay. This view is pretty dumb. As you can see, there's no business logic here. The only things that are interesting to this view is like do some UI changes whenever the state changes and send some events whenever it's necessary. In this case, just a load event on the onResume. Okay. I hope there are no questions on the view. Now for the next part is the view model. If you use this pattern, you end up with a view model that looks like this one. This is basically getting a use case, clean. Everybody loves them. We're going to have a channel, of course, a channel that is going to be receiving all the state changes. We're going to have a method that is going to receive these events. And of course, we're going to have another one there that is basically going to be reacting to those events. Whenever this view model receives an event, it's going to do something. In this case, when it receives the load event from the view, it's going to trigger the load of information from backend. This method is pretty simple. Basically, offers the state to the UI to start showing the spinner because we're doing something, of course. We're going to get the items. And if the items are empty, we show an error. If the items aren't empty, we just send that information to the UI. Pretty straightforward, pretty simple. If you apply this pattern, you end up with a really nice, clean implementation of your view models. You end up with really easy to follow streams. And if you apply like the solid principles perfectly, this is enough for you. Like you have a really nice functional application. But of course, the world isn't perfect. And all of us probably have a nice view model like looks like this. That screen that just keep piling up features and we end up with like a ton of use case imported there, a ton of events that are happening, and with so many methods that we don't even know what is in there. So how do you feel whenever you receive a ticket that is like to fix a bug on this thing? And I'm not going to just get started on like the PR reviews or all the things that you need to go through just to understand what is happening in that mess to do something about it. Now, don't worry. Of course, this is an extreme, but as I was saying, probably all of us have something like this in our code. And that is where the composite ViewModels come to the rescue. Now, what is the deal about these composite ViewModels? First of all, a small disclaimer. I have heard about this from an article with the same name from Sergei Shafarenka, which I'm probably mispronounced it, and I'm sorry for that. The link is here. Don't worry. At the end of the talk, I have like a list of all the references, so no need to start taking screenshots now. Now, what is the deal with these composite view models? As I was saying before, what? Oh, link is not nothing. I thought it was a question. As I was saying before, we end up with really lengthy view models if we're not careful. And I'm not going to start talking about how we are violating the solid principles in there. But the idea with these composite view models is to split those behemoths into smaller pieces that are easier to maintain. Now, how are these going to work? First of all, let's go back to our normal UDF implementation. We have our view, we have our view model, events going from one place to the other, states going back. The whole idea of this is to grab that view model and split it in small pieces. And the way we're going to do it is for each event that is going to be sent from the view, we're going to have like a small helper that is going to handle that event and is going to do something. Those handlers and small workers are going to be called delegates. Now, the interesting part about delegates is that the delegate is not going to care about all the events that are coming from the view, but are only going to take care of one of those events. Okay? This makes us this makes it easy to split all the information that is being handled in the view model, and basically we create some sort of like use cases, but for each of the event that comes from the view. This kind of approach is going to remove the responsibility of the view model to handle the event and react to them, and it's going to become basically to dispatch the events to the right delegates. Now, the ones that are going to be in charge of reacting to the specific events are going to be the delegates. And of course, since the delegates are going to be reacting to them and doing something, they are going to be outputting a state back. Now, of course, those states are useless in the view model, and the view model needs to be in charge of sending those states back to the view because the view model doesn't care about the state really. So again, this is going to shift the responsibility of updating those view states from the view model back to the delegates. And the only responsibility of this view model, again, is going to be to dispatch those states back to the view. And this is the whole idea of the composite view models. Basically, we grab the view model, we grab all the events that are being handled there, and we split them in smaller classes to be handled. We convert like this view model, instead of being like the core brain of whatever is happening, to just a channel to go from the view to the delegates and to the delegates to the view. And as Mario said, there are going to be questions there. I'm going to that part. Basically, the view model is going to be the one that is going to register the delegates, like it's going to be the one registering all the delegates that are going to be using to the view, because the delegates don't know anything about whoever is using them. The delegates just care about receiving that event, doing something, and returning the state. So the view model is going to be the one in charge of registering the right events to the right delegates and exposing those to the view. So basically, it becomes a channel. Now, of course, this diagram is really pretty, but something that it's nice to take into care about this, like, why do you care about this strategy? Like, if you have UDF and it works for you, I'm happy. But if you have these nasty big view models, something nice is that you end up with smaller classes. And the smaller classes are good for your soul and are easy to maintain. And they're like, whenever you need to change something, you just go to the specific class that you need to change. Another thing that is really nice is that each delegate only handles the events that are implemented in there. So whenever you need to do some changes or need to debug something, you just go to the specific delegate instead of swimming in that lengthy view model trying to find out where the hell those logic is. And the third thing is that adding new functionality, instead of needing to modify the view model that you already have there, you will only need to create a new delegate and register that new delegate inside the view model that you already have. So basically, the only thing that you're going to be needing to do is create more delegates and subscribe those delegates inside that view model. And someone unmute himself. Okay. And this is why this is nice. Of course, this is only pretty words and pretty things, and we need to see some code. So we're going to see some implementation of this. First of all, another disclaimer. Small disclaimer, the article that I said about Sergey, he's using Node to implement this. If you haven't heard of Node, it's a really nice library for state handling, and the link is there. Again, all the links are at the end of the presentation, so don't worry, don't take screenshots about this. But in this talk, of course, when I read that, I realized that this was a nice use case to be implemented using channels. So I'm going to be using channels for this demonstration. And how are we going to be doing that? Going back to our diagram, we can see that there are two main flows of information. The events going from the view to the delegates, and the state going from the delegates to the view. The events are easy, like since there are triggers, there can be just like simple suspend functions, just like a small net of calls there, and nothing really fancy there. The important one is the states, because we want to move all the states coming from the delegates, like just grab all of those and create a single stream of states to go back to the view. And that is going to be the work of the view model, and that is where we're going to be using the channels. How I did this, basically, I created some small channels in the delegates that are going to be the ones in charge of handling the state queue inside the delegates. I'm going to have another channel, the view model, which is basically going to be accumulating all these states coming from the delegates and sending those back to the view. Okay, that is the main idea of this implementation. And of course, we're going to see some examples of it. First of all, the view. The view is going to stay basically the same as with the UDF because we're not going to change anything in there. It's going to be pretty dumb, beautiful, perfect like this. Just listening to the states, doing something. Now, the new player is the delegate. The way I did it, as I was mentioning, is basically I'm going to create a state, a channel that is going to be handling the states of this specific delegate. I'm going to be exposing a function that is basically going to be listening to those event changes. And I just created some helper functions to expose the channel for the subscriber, in this case, the ViewModel, to subscribe to it. And of course, clear, because if you don't close your states, I mean, if you don't close your channels, you are doing something really wrong. The next part is the ViewModel, which is a more interesting class. Now, what I did here, as you can see, I went a bit crazy with those synthetic things. Anyway, I'm going to be receiving a list of delegates, which is the one, I clicked, which is the one that is here. And that list of delegates, I'm going to be registering to them on the init. Here, I'm going to also have a channel, which is going to be the one channel that is going to be registered on the view that is going to accumulate all those state changes. When I register to the delegates, basically, I just go to the list, and for each of the lists, I subscribe to it. And the other helper methods, which is the send, which is basically whenever the view sends an event here to the ViewModel is going to go to all the delegates to check if one of them can react to it. Small note that I forgot to mention here, whenever an event is received to the delegates, I am returning a Boolean, and that Boolean basically signifies if the delegate is handling that event or not. So in this end event, basically, I'm going to look through the delegates to one of them that handles that event. And when I find it, I'm just going to stop, which is what is happening here. And of course, I'm unclear because, again, if you don't close your channels, you're doing something wrong. So this just clears everything. OK? Now, of course, we are going to see an example of this working. And the application that I created is a simple one, which is this one, which basically shows a loading. And then you have a nice grid with a lot of elephants and its names. OK? Now, how I did this. This is basically the same example as I showcase on the presentation. We have our view delegate, we have our state, we have an event, the subscribe, and the clear. Composite ViewModel, again, is exactly the same. And please let me know if you can see the code clearly. If not, I can open something bigger. The Composite ViewModel, as I was saying, is just registering the delegates, well, receiving the delegates, registering to them, sending things, and clearing things. As I said, this is exactly the same example as in the presentation. Now, what I did here was create another base composite view model, which basically is going to be tying those generic view model and view delegate to the specific state and event that I'm going to be using in this view, which is basically what I'm doing here, just a wrapper, basically. That state is going to be a simple one, an ICL class, which is going to have the loading state, the show data, and the error one. And the event, I'm just going to be using load. As you can see, there's a random clear there, but I'm not using it, as you can see. The event is basically just going to be load. Okay. Now, our view ends up being like this. It's going to be receiving the view model. There's going to be some adapter, boilerplate, whatever. We don't care about that. On the resume, it's going to send the load, and whenever it's observing it, it's just basically what I show you on the presentation. I'm going to be reacting to those states. Now, how are going to be the load delegate? How is going to see? Now, this load view model delegate is going to be the one in charge of listening to the load event and react to it. This one is going to be receiving the use case, is going to be extending the base view model because I want to use the specific events and the states from this view, which is that part. And of course, I'm overriding the on event and the load items. On an event, whenever I receive an event here, which again is the one being sent from the view model, I'm just going to check if that event is the load event. If that event is the load event, I'm going to react to something and I'm going to return true. If I don't receive a load event, I don't care, I just return false. Okay? Simple, I guess. Now, if I receive the load event and the load items start, as you can see, it's just the same logic as I had in like my original view model. It's just a copy paste from it actually. And it's just going to be like offering the loading state because we're going to be doing something. We're going to get the items from there and I'm going to show that there. And that's it. That is my delegate. As you can see, it's pretty simple. Whenever I receive an event, I do something. That something is basically a function that I just copy pasted from my original view model, which is this one, by the way, which I'm not using anymore. As you can see, just copy paste. Now, this is a loading delegate. And let me open my component. Now, how I'm going to tie this delegate there? I'm using coin for this. So sorry if you're not familiar to this. It's basically dependency injection. basically, the way I'm going to be doing this is I'm going to use the list composite view model, which is an extension of my composite view model. And for the delegates, I'm going to be subscribing my new delegate, which is going to be the load view model delegate. Now, whenever the activity, okay, whatever. Whenever the activity sends that event to the view model, which the view model is my list composite view model, by the way, that event is going to be catched, is going to be sent, that is going to be received on the loading delegate, and the loading delegate is going to go the other way around. So when the load view model delegate returns these states, my view model is going to be listening here, and whenever it receives that state, it is going to send it on that state queue, and whenever that state queue is updated, our activity is going to react to it. So that's why, as you can see, this works. Boom. Now, the interesting part of this is, since I'm already abstracted all the logic inside my composite view model, which is this one, that has the core logic and everything is super generic, my list composite view model ends up looking like this. There's nothing there. I'm not doing anything. I'm just basically extending and tying the super types that I need on the specific view, and that's it. Like, for the rest of the view models that I need to create and everything, I just need to make sure that I'm defining the state, defining the type of event that I'm going to be using in that view, and registering the right delegates for it. And that's it. Whenever you want to create more functionality, you will only need to create a new delegate. Then for that delegate, you will just only need to go to your, in this case, my coin component, and just add it there. I don't need to do anything on the view model, basically just add something here and make sure that my activity is calling to those events and reacting to the state changes related to it. And that's it. Pretty simple, pretty straightforward. And as I mentioned, it works. And that's it. Here are the reference in case you want to learn more. As I said, I didn't lie. There's everything. Any questions? Hope it was clear. Yay.
Thank you very much. I always hate it when nobody speaks.
Thank you. As I was saying, it's a pretty nice strategy because you end up with really small classes, as you can see. Like the core logic is just in small delegates. The delegate, this is my lengthiest delegate, my only delegate, but details. And that's it. There are some room of improvement, of course. I was thinking on probably defining some sort of generic way to handle this event, but it was an overkill. And the main idea for this would be to create those, instead of creating base view models and base delegates, I would create one for each of the views and then use them on the view model, and the view model be the one defining those things, because you don't want to start mixing up all the states and events everywhere. So in that way, you end up with a really clear and really easy to follow logic in your app.
You don't allow handling of the same event twice, right? Because you return on the first match.
Yes, basically here. Basically, I go through them, and whenever I receive the true one, this is finished. So whenever I have a delegate that is already handling it, that's it. I can have as many delegates as I want. And the issue here is that the first one that returns true is going to be the one called. So you just need to make sure that you are not like adding delegates that react to the same thing, because then you're going to have some weird behavior.
Yeah, I was thinking if it makes sense that two would react to the same, but then they should be one, I guess.
Yeah, exactly. You can also have like several events register on the same delegate, in case, for example, that my load delegate for some reason also had like a different logic, but not so different on the refresh. You could probably also catch it here, change it to a 1, and just like when you receive that event, do something. So basically the responsibility of the events that you're handling, it's on the delegates. Any more questions?
So we have one in the chat. Are you using this in production, or is this a concept?
I created the concept. Basically, when I read the article, I just created it. I haven't used it on the wild, but I'm going to probably publish something on Medium and share, of course, the GitHub repository, which is on the slides as well. Here. So if you want to take a look on the thing I just did, you can just go there. And if you want to play with it on production, be my guest. Let me know how it goes.
I have a question. Would you take it to your Android team internally and propose to do it?
Of course I would. Mario, do you want to do something about this in our code?
I have no decision powers. I can just talk nicely.
I would probably suggest it. It will be a bit tricky. Well, not so much. It wouldn't be that hard to migrate to this kind of a structure, because basically what you're doing is just grabbing the ViewModel and splitting it. So if you have like a really lengthy ViewModels, it makes sense. If you have a smaller ones, probably not so much. But at least for some ugly ViewModels that I'm thinking about, it would be nice to have this kind of logic separation.
Yeah, there's another thing I really like, that like for the use cases, you don't have to have it all in the ViewModels. You can have it in the delegates.
Exactly.
We have a question from this little page, which is from Anonymous. Do you have an example for composite ViewModels with data binding?
No, but I mean, I don't have anything of data binding on that sense, but the data binding part will be part of the view. So, I mean, it doesn't, like, if you want to implement data binding there, you can just do it on the view layer, I guess. Or something. I'm not sure. Like, I don't have an example.
Oh, that's also a fair answer. I just posted the link again. If you feel like writing down the questions over there, please go ahead. But also, if you have one question you want to voice right now, feel also free.
Okay.
Then I'm just reloading one more time the page. And since there are no more questions on this side, I don't see more questions on the channel. I would say thanks again for the talk.
Yay.
Awesome having you here.
Perfect. Thank you. So then that's it. I'll give you the power back.
Please, and thank you. And I transfer the power over to Akayash for going with the flow. If you are in the channel. I saw you before.
Oh, wait.
Sure.
Yeah, my laptop seems to be freezing.
Always those Macs, right? Sorry, I voiced opinions again.
Yeah, it's exactly at the right timing that the whole thing started freezing.
Yeah.
Okay. Yeah, are you ready to get wet? And
yes.
I hope you're wearing waterproof clothes. Okay, do you see my screen?
Yes.
You see the slides?
Wow. Yes, we do.
Okay, perfect. Wait a second. Yeah, okay. Hey everyone, thank you for bearing with me, and thank you for joining. So I'm Akshay Chodia. I'm based in Berlin, Germany. So I work here as an Android engineer at Clue. So Clue is a female health company. It's also based in Berlin. And I'm a Google developer expert for Android. And today, we are going to talk about something which many people are excited about, that is Kotlin Flow. So the goal of this talk is to tell you why Kotlin Flow was designed, some of its basics, show you what makes Kotlin Flow special, And if you think it is special, then how you can migrate to Kotlin Flow, and most important, testing. So before we dive into Kotlin Flow, let's rewind a little bit and look at what Kotlin gave us. That is coroutines. So coroutines, like they simplify asynchronous programming in general, and especially on Android. So let's take an example of a synchronous function over here, like called as show user. So this function internally loads the user from the database, and so this blocks the thread. So when this function is called, it blocks the current thread and waits till the user is loaded from the database. So this blocking is bad because at this moment the whole UI is frozen and the user is unhappy. And once the data is actually loaded from the database, the render function is called, which renders the data on the UI. So there are like multiple ways to tackle this synchronous code. So let's look at like how we can tackle this problem using coroutines. So to tackle that, so let's take the original synchronous function again. So first, what we will do is like we will mark the function with the suspend keyword. Of course, we will also need to mark the function suspend to, since we also want it background. You can see that by just marking it as suspend, the code will already start running in the background thread. But there is a problem. The render function needs to be called from UI thread since it's touching the view hierarchy. So to change the context, there is a function called as like with context, which allows you to switch the thread inside the suspending function. And here we can like change the thread to main and then call the render function. And that's it. Like that's pretty much how you would change the asynchronous code into asynchronous with coroutines. So let's like dive in a little bit deeper and see how it works internally. So so it will start by calling the show user function, and since it's marked as suspend, it will automatically switch to a background thread or the thread specified while launching the coroutine. And when and then the user will be loaded from the database on this different thread, while the main thread continues to go ahead without waiting for anything, that is not freezing or blocking the user experience at all. And then because of the with context function, it will switch back to the main thread, and then it will call the render function on the main thread and display the UI. So one key thing to remember is suspend functions can be called either from another suspend function or from a coroutine scope. So let's look at what coroutine scope is. A coroutine scope basically represents the scope of the coroutines. So each coroutine needs to run in a scope, and when the scope is destroyed, all the running jobs inside the scope are also like stopped or cancelled. So this scope is like generally associated with the lifecycle for simplicity. For instance, on Android, like for example, on Android we have activity which has its own lifecycle, and so this scope, this lifecycle scope of activity can be associated with the coroutine scope. So let's look at an example to help understand this better. So for example, in order to call our show user suspend function from a normal function, we would need a coroutine scope. So on Android, these scopes are already implemented, luckily, for us. Like for example, like the lifecycle scope. So this lifecycle scope is part of the lifecycle KTX Jetpack component, and it is provided to use coroutines from activity or fragment, and this scope is associated with the lifecycle of the view controllers, in our case, which is the activity or the fragment. So this scope provides the magic of automatically clearing or canceling all the subscriptions or jobs, as called in Kotlin Flow world, running in the specified scope when the activity or fragment is destroyed. So the launch function here is used to start the coroutine, and as soon as the launch is called, it will immediately start the coroutine. That means like coroutines are hot in nature. This is also one of the reasons why coroutines are not like one-on-one replacement for reactive streams. So you can think of like a coroutine scope is kind of a subscription management system built by the Kotlin team, and it's associated. It's more or less associated to a lifecycle. This concept is called a structured concurrency, and this is what makes Kotlin coroutines so powerful, and also helps developers from like preventing the leaking of their job or subscription. So let's go into the important question, like why Kotlin Flow? So why did it come in? Why was it built in first place? So with the growing usage of Kotlin and the love for Kotlin coroutines, people express a lot of interest in having a pure implementation of RxJava to leverage all the amazing feature which Kotlin provides and which we all love. But the confusion with the team, the team had this confusion was like, should they, do some magic on top of RxJava to leverage Kotlin, or build a whole new library from scratch? So in case you don't know, Rx Kotlin actually exists, but it doesn't really leverage all the Kotlin features. So at the end, it's important that that any new library raises the bar compared to existing ones out there, and is not just a replica with slight improvement. And that's what Kotlin Flow does. It does raise the bar. So let's look at like how does it raise the bar and what's so special in Kotlin Flow. So the first thing is like Kotlin provides null safety in the stream. That means you cannot send null values in the stream. So this is not something new. RxJava 2 also has it. The second is like it provides interoperability between other reactive streams and routes. So this is a key thing. So from easy API to convert the flow to any reactive stream like RxJava Flowable and the reverse. Also, you can combine flow and coroutines. We will see this later today. Third is like this one is really cool. I really love this one. Like that Kotlin Flow and Kotlin coroutines like support Kotlin multi-platform. That means you can actually use coroutines or Flow on any of the supported Kotlin platforms like JVM, JS, or native, or you can like toss it in the common code or the shared code for Kotlin multi-platform projects. Fourth is like there is no special handling for back pressure. Like there is like literally like pretty much no operators for handling back pressure. This is because of the suspending nature of coroutines. They kind of help to like magically handle this. Another point is like there are like very few operators, and they are like super simple. So this directly correlates to the ease of understanding. And the reason why there are like fewer operators is twofold. So one is like because of Kotlin's extension function magic, and second is like because of coroutines. Since coroutines, the suspending nature of coroutine allows to have a same operator for synchronous and asynchronous code. This drastically cut down the number of operators needed. And also it has the perks of structured concurrency, which we saw before. Okay, now we saw like what was special. Let's look at what is Flow. So Flow is actually based upon the reactive stream specification. This is the same as like RxJava 2, 3, and Reactor library, I guess. But yeah. So you can think of it like a very similar to a list or collection. Similar to a list of collection, it also has all the operators like map, switch map, etc. And it's built on top of coroutines. And the important thing is like it's cold in nature, unlike coroutines. So let's look at some basics of Flow. So essentially, like there are two components, an emitter and a collector, where the emitter emits new values and collector receives the values. So here is an example of an emitter. And this emitter returns a flow of string, very similar to how you would return a list of string. So there are like various ways of creating a flow using something called as flow builders. So they are functions provided by Kotlin coroutines library. So they internally create the flow for us. We will like look at like what exactly it does internally in the next slides. Since Flow is cold, nothing inside the flow builder block will be called until there is a subscriber or collector observing the flow. Yeah. Yeah. So let's look at the other side, that is the collector. Here we have the main function which gets the flow inside the run blocking function. For people who haven't used coroutines, a run blocking function is a blocking coroutine scope. That is it blocks the current thread until everything is completed. So we need the coroutine scope. Since the collect function is actually a suspend function, so is the emit. We will see ahead like why they are suspending functions in first place. So let's understand how things are working internally. So initially, the main function calls the stream function. this will immediately return the flow back. And then we will call the collect function on the flow, which essentially means we are subscribing to the emitter. And as soon as we subscribe to the emitter starts emitting the values sequentially upstream, and the collector receives them and prints in this case. And the same loop happens, the same loop happens, and the next values are emitted and again printed. And so this goes on till the emitter has no values. That's when the execution moves out of collect and is complete. So let's dive a little bit deeper and see how this is working internally. So as I mentioned before, flow is based upon two components, that is a collector and an emitter, essentially like they are interfaces. The following represents the interface for collector, which exposes the collect function, and the emitter interface, which allows emitting values. The key thing to note over here is that both the functions are suspend. This is what allows the magic of back pressure, and also gives the ability to do structured concurrency, and also allows to do interoperability with coroutines. The funny thing is, the whole mechanism of flow is essentially emit and collect calling each other, and that's it. Like that's how the whole flow is built upon. So flow loves coroutine also because it's built on top of it. So let's say you have a function which loads data from database. Since this operation takes time to perform, you would ideally want to perform it on a background thread. So you would start off by marking it as suspend. And the funny thing is, you can directly call this function from the flow block because the flow block accepts a suspending lambda. So the flow block accepts a suspending lambda, and also because the collector and the emitter are also suspend function, which is just great. So let's look at the core ideology of flow and how they make our life easy. So with flow, you can define or switch the thread by using an operator called as flow on, which takes in a dispatcher, which in this case is IO. So the operator sets this specified thread only upstream. So that is anything above the flow on will run on IO thread. So nothing below, so the things below, so for example, in this case, there is a map operator below the flow on, it will run on a different thread and it will not be the IO thread. So this concept of preventing context from leaking is called as context preservation, where the context is encapsulated and it's never allowed to go downstream. So there is only one way to change the context of a flow. So if you compare this to RxJava, where it's like super confusing, especially for beginners to understand which thread their code is going to run on, you can see in the above example that only the first subscribe on is applied and other is ignored. And this is super confusing when you're working in a large code base or like you're new to RxJava. So not to mention that there is also another operator to change thread, that is observe on, and this again has a different behavior. And this is like a facepalm moment. So exception transparency. This is the second principle or ideology of flow. So flow implementations like never catch or handle exceptions that occur in the downstream flows. So they catch all the exceptions for upstream. This is again due to context preservation. So this means there is only one operator to catch error, and which is the catch operator. So obvious. So let's look at an example. Let's take the previous example of flow, which tries to get the value from the database and emit. As you can imagine, anything can happen while loading from the database, and the database and the operation might throw some sort of exception. So very similar to a try catch block, flow has a catch operator, which will catch any exceptions thrown above. So a point to note over here is like any, so if there was an exception after the catch operator, so it will be not handled by the flow. So it goes to something. So when each scope has this handler, so it will be handled over there. And if you don't have this handler, then there will be like a runtime crash or something. So it's a nice gotcha that you need to be aware of. And in case you don't want to use the operator, you can even use the classic try catch block. It will behave exactly similar to the catch operator. But I would recommend to use the catch operator itself. But there can be use cases where you want to use the classic try catch. So during those times, just make sure to ignore the cancellation exception, because you don't want to emit an error when your flow or coroutine was canceled, when the activity was closed, or went on pause or something like that. So this is exactly how the catch operator works internally. Or you can specifically handle the exception you expect to see. For example, in case of database operation, you know that the operation might throw an exception. Then you can.
Hallo, Anita. Klar.
Weird. So you would want to handle the specific exception in this case. So the value, so you can so also the another point to note is in the catch you can emit values. So the great thing about collect is that collect is the single place where you handle all types of cases that can be either success or failure. So this makes it super transparent, and also gives a single place to handle all the cases of your code. So I would recommend to toss in seal classes so you cover all your cases, and it also looks nice. So at this point, it might be confusing to you to understand when to use suspend and when to use flow. So use suspend for one-shot operations like inserting into database or some network operations, and use flow when there is a stream of data involved. So usually when you want to listen to the changes in the data and update your UI. For example, getting the updates whenever there is a data change in the database, and update your UI. So let's look at channels now. So channels are communication primitives. So they allow to send and receive data between different coroutines. So the idea behind channels is to use communication for sharing information instead of using a shared mutable memory, which is known to provide deadlocks and other good stuff. So coroutine that sends information is often called as a producer, and the coroutine that receives or consumes the information is called as a consumer. So again, you can see that the channels are hot in nature, and hence they are not always the best candidate to use. And like I said, channels are low-level primitives, and Kotlin Flow internally is built using coroutines and channels. So generally, you should try using Flow as often as possible for your use cases. Just because with channels you need to be a bit more careful with its hot nature and how cancellation works with channels, etc. I would also the Kotlin team is also trying to provide alternative APIs in terms of Flow. So right now some of the use cases are covered using channels, and they're trying to provide maximum APIs to use Flow directly instead of channel. We'll see one such example. So let's take an example of channels to understand a bit more of what channels are and where you can use them. So let's say you are an app which needs to show some result after user enters the search query. So for which I have taken here a conflated broadcast channel, which is a very mouthful name. So conflated broadcast channel is basically a broadcast channel or a send channel. That is, it allows to broadcast or send values. And the conflated means that only the recent values are emitted, and every subscriber immediately receives the most recently sent value. And somewhere from your activity or fragment, when the search text changes, the user types a new text, and you would call the send function on the channel, which will immediately emit a new value to its observers. And on the receiving end, you can convert the channel to Flow and do some map operation to get the result for the specified search query. And you would throw in distinct until change to take only unique results, and finally render the result on the UI. But like I said, channels are low level, and you should try to use Flow as much as possible. And also Kotlin team is working on making such things available. And one such class right now is Stateflow. So Stateflow is a new primitive, and it's designed to emit updates to its collector, and it is meant to eventually replace conflated broadcast channel, which we just saw. So state flow is it's pretty similar to how we saw in the previous example. So there are like two things over here, like the state flow and a mutable state flow. The key difference is the mutable word. So mutable allows setting the value to the flow, and usually like make sure when you're exposing your state flow outside of your business logic, expose it as a state flow, not as a mutable state flow, to avoid the side effects because of the mutability. So what you would do is like similar to the channels, whenever there was a text change, set the new value to the flow, and whenever this value is updated, the collectors will receive it. And then like every other flow, we can just directly collect it and listen to the updates. So one key thing to remember is the operator distinct until changed is automatically applied with state flow. And the good thing is that the IDE will warn you if you forget, if you accidentally add distinct until change. So that's good. So at this point, like you are aware about flow, and maybe you are liking it, and so let's look at like how you can migrate your legacy code to flow. And a lot of code bases are stuck with like legacy code, either like callbacks, RxJava loaders, or any other asynchronous programming APIs, and it's totally fine. So if it's working, it's great, but the problem lies with the slower updates and the hard maintenance and refactoring whenever there is a new requirement. So this usually like slows down the efficiency and the velocity of developing the given requirement. So like there are two major things to do for migration when you want to migrate from legacy. So this migration process, which I'm putting over here, is just my recommendation. And also, this doesn't just apply to Flow. You can do it for RxJava 3 in case you want to migrate to RxJava 3, but it's slightly more specific to Flow. First is like setting up the process is super important. So the whole team works towards a single goal of migration. So there is no rule of thumb over here. Like I said, these are just my recommendations. So the first order of business is to discuss with your team and try to figure out what alternatives to pick that works for your team and your use case that you're trying to solve. So I would recommend to do something as followed to get started and decide what other tools suit the best for your code base. So start off like with setting up a meeting with the team and list all the possible alternatives like RxJava 2, 3, or Flow, and discuss the pros and cons and advantages of all options. It's also best if the team gets to try out the solution the alternative which you're planning to go ahead with. And this might include doing a small sample app, giving an internal presentation, talks, articles, anything, so that everyone is on board and comfortable. And after that, like it's very important to evaluate like how hard the migration for certain options might look like for your code base. Also to evaluate like how the learning curve for the new joiners in the team would be. For instance, we at Clue, evaluating if we have RxJava 1 as legacy code, and we had to evaluate, like we were evaluating RxJava 2 and 3 at the time, and for our code base it would have been super hard. And we also tried like Flow, and after getting comfortable with it, everyone liked it and everyone felt comfortable with it, and that's why we decided to like move from RxJava 1 to Flow. So at the end of these steps, you have a common goal in mind. For instance, you have the goal to migrate from RxJava 1 to Flow. So once you have this common goal, you need to, the second step is like setting up the foundation. So this is very key to the whole migration, because this is what will motivate the team to write new code in Flow or whatever you have decided within your team. So you don't want any developer to start, start thinking to write a new feature in Flow and then realize there is no testing framework or something like that. And this will just make make the developer go back to their comfort zone. And since all of us are humans, we will go back to our comfort zone. So to set up the foundation, you can start with like setting up guidelines, the standard practices, like of how the team wants to use Flow throughout the code base. So the second step is like setting up the necessary base classes for your code base and to work with your architecture. Like for example, if you're using MVP, you might want to write a base class, a base presenter or something which has this coroutine scope to allow clearing up all the subscriptions or the jobs. So things like that, this is where you will set up all the base classes necessary, including the dependencies, etc. So the third is like setting up the testing framework. This is easily the most forgotten one. So set up the testing framework so that everyone can, so whoever writes the code in Flow or whatever is decided upon, and so with the framework, it's easier to do testing with Flow or anything. So this might include like setting up the dispatchers or writing some utility class to do so. And fourth is like expose this so every code base has this common features or common things which are frequently used in the app, like getting the user details, like email address or something, or access token, something like that. So expose those common APIs. So it's ideal if you expose this common APIs as Flow, so it doesn't block when you're writing newer features. So let's take an example. Let's say you have this existing interface which exposes an observable of user. So one approach here is to convert this function to return Flow or coroutine, which is just great. Like, I mean, if it's possible, just change it to Flow or coroutine, but it's not always feasible. So what I would recommend, so another approach to the problem is like to duplicate this base API and expose this duplicated API as Flow or coroutine. Also, like you could also throw in the deprecated annotation so that everyone uses the new function which is written in the Flow and avoids the legacy one. And eventually, with time, as everyone uses this new function, you can remove the legacy function at some point. One pro tip over here is like try to extract the business logic between these two functions in a private function or something, so that whenever there is a change, you don't need to update it twice in the old function and the new function. So try to do so. I mean, it's not always feasible, like, but whenever you can, just try to extract the same logic in a single function. And yeah, deprecated. Okay, setting up safeguards. So now that we are like super motivated to write Kotlin coroutines and we have these guidelines and everything and everyone is working towards it, we need to set up the safeguards. So these safeguards will kind of prevent or force the team to write more and more code in like Kotlin Flow or coroutines or whatever was decided, and also help you like convert more and more legacy code. So these safeguard can be like, for example, each code base. So this can be like the ensuring that each new code that is written using Kotlin coroutines or Flow, and this can be verified during peer reviews, and you can point out in the peer reviews that like why it was written in the legacy code. So this can be a really good safeguard. Also, the another approach would be ensuring that whenever the legacy code is touched, the developer has tried, because it not be always feasible to convert it to Flow or coroutine, but like at least has tried or has a really genuine reason that couldn't be that the certain legacy code couldn't be converted. So these safeguards would be really good to so that like everyone like continuously keeps moving to Flow or whatever new is decided. Another thing which I really like is like doing a quarterly or a monthly checking of progress of how the gradual migration is going on. This is also a really good idea because this also motivates you, motivates the team to see like the progress and be motivated, like, okay, we are moving towards the goal. And of course, like all other ideas which will pop into your brilliant minds. Okay, interoperability. So the key to success of a Java Kotlin migration was interoperability and the ease of using one from another. And this opened the doors for gradual migration. So similarly, having this ability to quickly interop between legacy code and the Flow or coroutines can drastically change the landscape. And Flow provides an amazing API to convert any legacy-based or callback-based API to Flow. So let's look at an example of a callback function. Let's say you have this legacy listener, which is triggered each time the document is updated. So not to mention that you need to remember to remove this listener when the component is destroyed. For example, when the activity is destroyed, you remove this listener. So to convert it into Flow, Flow provides an amazing API called as callback Flow. So where you can write the legacy listener, aka callback, and whenever the callback is triggered, you call offer, and offer basically means that you emit the value whenever there is a change. You emit this value. At this point, you would be wondering, like, we also need to remove the listener at some point, right? Luckily, like, Flow provides this function called as await close, which is called when the flow or coroutine is cancelled, where you can like safely remove the listener. Finally, with code comments, it looks something like this, which a lot of people forget to write. Just saying. So now we saw like how we can convert the callback to Flow. Let's look at how you can migrate from RxJava to Flow. The goal here is to not tell you to go next moment and migrate your code base to Flow. I mean, that would be great for your own projects, obviously. Okay, so the good part is like Flow and RxJava follow the same reactive stream specification. So in theory, it's very easy to convert data streams from Rx to Flow and the reverse. So like there are like two ways to convert. First is like either refactor your RxJava implementation to return Flow. Well, it's time consuming, and sometimes you just want to switch the type, so you can gradually move to Flow. In those cases, you can use the asFlow extension function to quickly switch the type between flowable and observable to Flow. Similarly, the same can be done to convert the observable or flowable to Flow whenever you need it. So this is part of a different dependency, which is like Kotlin X Coroutines RxJava 2. You need to add this dependency to have this extension functions. So here is like a very quick comparison of terminologies between RxJava and Kotlin Coroutines Flow world. This is what I stole from Clue's documentation. So in my defense, I created this table at Clue, so I think I can steal it fairly. So use this chart as a reference whenever you're new to Coroutines world or working on migrating from RxJava to Coroutines Flow or the reverse maybe. And you can see that like we have covered pretty much everything mentioned in there, which is good. So let's look at something really fun. So a moment ago, we saw the asFlow extension, which allows you to convert observable to Flow. But the funny thing is, like, this extension function actually uses callback Flow internally, which is so cool. So another thing is like if your code base might be stuck with RxJava 1 and you might want to move away from RxJava 1. So I would recommend to migrate to Kotlin Flow if you're stuck with RxJava 1 rather than migrating to RxJava 2 or 3. Since RxJava 1 bindings are not officially supported by the Kotlin team, I have created a library, the link below, for those who need it. So it offers the same API as we saw before for RxJava 2, and this API allows you to convert from coroutines to Flow and Flow to observable, things like that. Okay, now to everyone's favorite topic, testing. So testing Flow or coroutine is pretty easy. Let's take a simple flow of string and write the test function and use the run blocking coroutine scope because we want our test to wait till the coroutine is completed. So like I said, Flow is similar to a list or a collection. So you can use take operator to pick the first value from the stream, and then convert the flow to list, so you can easily assert it. Yeah, and then you can easily assert it, or you can write an extension function, which I again stole from Clue code. Again, in my defense, I wrote it, so I think you can steal it. So where you can use this one to easily assert items. So with the extension function, it would look something like this, a much more cleaner version. Okay, conclusion time. So here's a quick summary of what you learned today. So we revisited coroutines. We saw why Kotlin Flow came into the picture and what makes it so special. We saw basics of Flow, that is the emitter and the collector, and how they work internally using suspend and the magic of coroutines. We saw principles of flow, that is context preservation and exception transparency, and how they make our lives easy. And then we saw like how to convert legacy code to flow, or legacy or RxJava code. And then testing the flows and some pro tips along the way. To conclude, like Kotlin Flow raises the bar and makes reactive programming easy and gives us great Kotlin feature. That said, a lot of things are like still work in progress, and but more or less a lot of things are stable. But a bunch of operators or things like a share flow is one of such case, which is still work in progress and is still in the coming soon. And oh yeah, it should be there pretty soon. Just a note, like we are already using this in production in case someone has that question. So here are some further resources. I might be biased over here because I added my resources over here. So first is like the news app, which is like a complete app showcasing how to work with flows and other parts of the app on Android. And then go with the flow if you want to like revisit. So the whole presentation was made from these two articles. So if in case you want to read more or go deeper, then you can read the article. And lastly, thank you. Oh, and one more thing, you can scan the QR code or visit the link to give the feedback about the talk. And that's it. Thank you. I'll stop the share. Thank you.
Thanks for this awesome talk and for the round kick about like how do we do things differently. This was very exciting and awesome. And you can read the comments.
Any questions? Oh, wow.
I have one icebreaker question. Are you and Nicole, are you sharing your slides somewhere, somehow later on?
Yeah.
Cool. Thanks. Like just in case somebody wants to read along with the video or something.
Makes sense. Yeah, and in case anyone has any questions later on or when they check out the code base or something like that, just feel free to like tag me on Twitter and ask those questions or reach out to me personally, whatever works the best for you. Okay.
Yeah, and same, like if you have a question, feel free to ask, unmute yourself, then it's better for us to hear you, or write the text inside the chat box. I just want to give it some more minutes to see how we see. The question is, how do you debug how do you debug the flow? Sorry.
So like, I mean, usually more or less most of the stuff you can debug using the IDE features, and it works pretty good, like how you are debugging normal code. That said, there is still a gap which can be improved. Like and the Kotlin team is aware about it, and they're working on a special coroutines debugger where it will provide more like data while debugging. So right now it already works, but it's not like so great that in case like you really want to go in, you cannot do it. So
organizatorical thing, Hassan, I would stop recording once we stop speaking, because then we can also go for something more community-related questions. That said, are there more questions? No, then I think, Akshay, thanks again for the talk. I can get you out of the stage now.
Thank you for having me.
Something, and then Hassan, if you press the button, we would come over to the bit more